So we're told that the initial temperature of an iron meteorite, which I call T sub I, is minus 105 degrees Celsius. Um, and that it enters Earth's atmosphere, and it wants us to calculate the minimum velocity that the meteorite must have before it entered Earth's atmosphere if it completely melts. Okay, well, if it's completely melting, that melting temperature of iron, I call it T sub M, is 1,538 degrees Celsius. We also have the latent heat here for the object. It's 2.89 times 10 to the 5 joules per kilogram. And the other constant is this heat, specific heat capacity of iron, C sub I, is 450 joules per kilogram times degrees Celsius. So we're going to assume that the final speed of the meteor, as it's completely melted away, is 0, and that all of its initial kinetic energy was used to heat the iron to its melting point. So its initial energy is equal to its final energy from the heat. So 1/2 mass of the meteorite times the velocity of the meteorite initially squared. That velocity is what we're trying to find, is equal to the mass times the constant C sub I. Let me write that here. C sub I times the temperature change. So we're going to have the melting point subtracted from the initial temperature, T sub I. And that initial temperature is negative 105. I'm sorry, I forgot that negative sign there. So up here, T sub I is negative 105. So minus a minus is going to be a plus. So that's going to end up being T sub M plus 105 degrees Celsius. And then added onto this, you have the mass times the latent heat, L sub F. Okay, so solving this relationship for V sub I, we notice that all the masses cancel because they're all the same. So V sub I is equal to the square root of 2 multiplied by C sub I times T sub M minus T sub I plus L sub F. So plugging in all those values into this expression, we find that the initial velocity is equal to 1,430 meters per second. And we can box that in as our solution to the question.